Good morning. I bet you're wondering why we're shooting this video. Why, as a matter of fact, we're doing this because we're forced to for a grade. If you would come over here, I'm going to explain polarity to you. Now you see, this is a large oxygen atom, and these are two hydrogen atoms. Now, together, these are all bonded to make a water molecule. Now, because oxygen has more protons and neutrons, it has a higher gravitational pull. So, it pulls in hydrogen's electrons, and hydrogen's electrons will spend most of their time with oxygen. This gives hydrogen a partially positive charge, and it gives oxygen if I can find my negatives, there we go, a partially negative charge. And so that would also give the other hydrogen a partially positive. Ariel, what are you doing? You got the table all wet.
I just did the water challenge. Why is this water sticking to me?
Because of adhesion, Uriel. Alright, now we're going to explain to you adhesion. Now, adhesion is when water molecules, or some other liquid form of a molecule, forms bonds with other molecules and clings to it. Now, if you can see here, let's say we dipped Brett's notebook in this puddle of water. Now, the logical thing to do would be to soak up all of this water, right? Well, that occurs through the hydrogen bonds, and so that's what allows water that is climbing up Brett's notebook to soak in and defy the forces of gravity.
Yes.
This has been adhesion. Alright, so as you can see, today it rained outside. Now, normally, without these hydrogen bonds in water sticking, we have random camera zoomage, but normally, if we didn't have hydrogen bonds, keeping these water droplets outside together when they fall as rain, we would just have mist, and when it would rain outside, it would just mist on us. And so these hydrogen bonds allow the water droplets to stick together, and that's what gives you rain droplets. Alright, so the next subject we're going to talk about is specific heat. Now, compared to other elements, water has a very high specific heat. And this can be displayed like when you're boiling water in an iron pot, and you can touch the side of the iron pot and burn yourself, and yet the water inside will still be warm, relatively warm, but not enough to burn you. This is because it has a high specific heat. Now, specific heat is defined as the amount of heat that must be absorbed or lost for 1 gram of water, in this case, to change in temperature 1 degree Celsius. Now, this has to do with, again, hydrogen bonds, because, as you can see, a lot about water is hydrogen. And so it takes more energy to break these bonds and raise the temperature of water. So if we had, say, an iron atom over here, imagine an iron atom or a molecule right here, a water molecule right here, and you heated this both at the same rate, the imaginary iron molecule would raise in temperature faster than the water molecule would.
Water has a much higher surface tension than many other liquids. This results in things like water striders being able to walk on top of water, or a glass full of water having the water stand slightly above the rim.
Surface tension is due to cohesion. Because of cohesion, all the water molecules want to stick together, and that's why the bug can stay on top of them without sinking.